Let's get busy with this one. Okay, so this is FRQ number 1. Let's see, there's a parabola that we're given. It says show that the line through this point with this slope is tangent to the parabola. All these questions on this one are really closely related to each other. Now let me give you guys a little image right here to help us contemplate what's going on. Alright, here's x squared. And then we got this random point, 3, -7, that's right about there. And it wants to know if the line that's going through this with the slope of -2 is tangent to this. Now I don't know if it is tangent, but I'm going to draw it like it is tangent. Okay, so I'm going to say that it hits this line or this curve right there. I'm going to say it hits it right there. And let's see, let's label this -3, no, sorry, not -3, 3, -7. And this has a slope of -2. That's how I knew that this line was going to go down. Because, I mean, couldn't you draw another line right here that's tangent to this, right here? Like the other way? Okay, which might be increasing, it might not be increasing, I'm not quite sure. But, there you have it. That's what we're looking for. We're trying to prove that that is true without actually graphing it. So, how would we be able to do that? Well, this equation is going to say y, the tangent line, y minus -7 equals -2 x minus 3. And if I simplify this, we'll have y plus 7 equals -2x plus 6. We're going to take 7 away from that, so we get y equals -2x minus 1. I don't know where that mark came from. Minus 1. Okay, so is this tangent to this? Now, there's different ways to solve this. So I don't want to shoot down any other way that you might have thought of, because it could have worked. It might work. I personally haven't thought of that way, or I'm just choosing not to talk about it. I'm thinking, let's just see where these two curves right here, or this line and this curve, where they intersect. Do you guys know how to do that? How to find out where they intersect? You guys ever remember doing that? We want to find this point right here. It's called a system of equations. So I'm going to write my other curve right here, and I'm going to solve this system of equations. So I gathered my information, I drew my picture, and now I'm thinking, if I do a system of equations and I find out where this point is, I might be able to find out what that slope is. Or I could just find out what that point is and see if it fits on this line right here. That's how I would be able to show that it is tangent. Okay, so let's use a system of equations. We're going to substitute x squared in for the y. Here we go. We got x squared equals -2x minus 1. Now, because we have a squared in there, we know that we're going to have to use some kind of factoring or something like that in order to solve this. So let's move everything to one side. We have x squared plus 2x plus 1 equals 0. So I just moved these guys over to the other side. And now I factor. So let's see, what times what gives me 1, but adds to give me 2. That'll be x plus 1, and actually 2x plus 1s. And that equals 0. So if I wanted to solve that, I would square root both sides. That would get rid of this 2 right here, and the square root of 0 is just 0. So I have x plus 1. I get x equals -1. So that means what I just found was the x value right here. The x value of this point right here is -1. Now how can I find the y value? Just take it and plug it in. So if I wanted to find the y value, you just got to take this -1, plug it into one of these x's, it doesn't matter which one, and you'll find the y value. Let's plug it into this one right here. -2 times -1 would be a +2, +2 minus 1 would be a +1. So my point is -1, 1. This point is -1, 1. Now, there's different routes you can go now. You can either take the derivative of this, get a y prime, and then find out what the slope is right here of that. Because we know that since this is a solution of this system, we know that that point works for both of these. And because of that, you can say, you can use the slope and everything, the derivative, to say that that this is a tangent line. But I like just saying, keeping it simple. Let's say that this line is tangent to that curve because it intersects the parabola at one point. So, I mean, there's not 2 points, right? There's just 1 point. I didn't get 2 answers, right? I just got 1 answer. I mean, I could have gotten 2 answers. I mean, if I draw another line like from here, I would get 2 answers, right? I would get 1 right there and 1 right there. But since I only got 1, I could say that it's tangent. Because they intersect only at -1, 1, this line is tangent. Questions? Okay, I'm going to repeat what I just said. Pretty much this problem is you have to find the system of equations and then show that they only intersect at one point. Now there is one condition where this line wouldn't be considered a tangent line. If I had a line, let's say I had a parabola like this, and I had a line that went like this, that line only intersects the parabola at one point, right? So, but I know it's not tangent because after it intersects that point, it doesn't stay on the same side of the curve. See, right, this one, it intersects right there, but it stays on the same side. It doesn't cross over to the other side of the curve. So, is our argument ironclad? Does it still prove that that this line is tangent? The answer is yes, because this is a parabola. If this line was vertical, meaning the slope would have to be undefined, but it's not, it's -2, then this scenario is not going to be possible. That's not going to come up, okay? Because no matter what, anywhere else, with any other slope, we're going to have at least 2 intersection points, or 1 if it's a tangent line. Okay, so let's look at this next one. This next one says, find another line through this point that is tangent to the parabola. Okay, so we have the same scenario. We got the same point down here, but this time we're trying to show that there's another line. How would we show that there's another line? I mean, visually, we can look at it and go, oh yeah, there's got to be another one. We're going to find the answer to this using another system of equations. And this was weird, because the first time I ever did this, I stumbled onto this answer. I had no idea. I'm like, man, how am I going to do this? And I just started writing things that I knew, and then it worked out. I was like, whoa, it was trippy. So, I thought first, I want to try to write this equation. I want to write the equation for this tangent line. And so I thought, okay, I got y minus -7 equals, and I'm like, well, I don't know the slope, and then I have x minus 3. Now, we don't know the slope, but we do know the slope, kind of. We know what this slope has to satisfy. We know that this slope has to satisfy y prime. And what's our y prime of this curve? 2x. Now, I say this often. Y prime is slope. That is slope. So take this guy right here and just plug him right into that. Now, it doesn't really solve our problem yet. This is what we get. We get y plus 7 equals, and we have a 2x squared minus, minus 6x. So I just distributed the 2x to both of these. Now I have this. How does that help me find out if there's another line that's tangent? So after I do that, I'm looking at this going, all right, I got 2 variables. In order to find the tangent line, I need the slope. And how do I make a slope? I make a slope with 2 points. I only know 1 point on this tangent line. I only know 3, -7. And so this x and this y, I mean, it should be satisfied by 3, -7. If I plug in 3 and -7 to these, it should work. So, anyways, I'm sorry. I'm going off on a tangent here. No. All right. I know. I'm sorry. So, what I thought was, well, if I have two variables and an equation, if I can get another equation in here that has the same x's and the same y's, then I could probably solve this problem. This x and this y are the same x's and y's as this. So we have another system of equations. Alright, so let's plug in that x squared to that y again. So now I have x squared equals 2x squared minus 6x minus 7. I subtract x squared from both sides because I need it to equal 0 so I can solve it. And then I see that and I can factor it. And so I get x, what is that, minus 7, and then x plus 1. And now you guys should notice something. I have x equals 7 and negative 1. Does that look familiar? That negative 1 is the same negative 1 right here. These are the two x values that you would get from the 2 points that would be tangent to a line that crosses 3, negative 7. Fascinating. So this 7 right here, I would have to plug that back into one of these dudes to find the y value for it. I have a 7 and a 49. If I plug it into the x squared, that's what I get. This is the other point that you need to form this second tangent line. So you're asking why I didn't plug in negative 1? Watch this. If I plug in negative 1 to one of these equations, I'm going to choose this one because he looks easier. Negative 1 squared is 1. This point is the same point that I found right here. So I don't really care about him. I want this guy. I want the discovery of him. The question says find another line through this that is tangent to the parabola. There he is. There's the other point. So you can do one of two things. You can take this point and find your slope, or you can take this 7 and plug it into the y prime to find the slope. Not the 3. The 3 doesn't work because the 3 would give you the slope right there at that point. We want the slope at this 7, which is like somewhere way up here. So if I plug 7 into my my y prime, what do I get? 14. So this is your equation. It is y, you could say y minus 3, no, I'm sorry, minus negative 7 equals 14 times x minus 3. Or you can say y minus 49 equals 14x minus 7. I would take either one of these answers. Either one of these answers is good. Look at this question. It says, is there a third line through this that is tangent to the parabola? Now, justifying your answer would just include explaining your work. You can say, well, from earlier, I only got two x values, a 7 and a negative 1, where a tangent line would intersect this curve, and 3, negative 7. Your work already proves it. You just have to reiterate it in words.